Hi. Today we're going to be talking a little bit about properties of solutions. All right. We've already learned what solutions are, how you're formed, also perhaps a bit about their calculations for their concentrations. But there are several properties that solutions have that make them different from pure water. Okay. And one of the main ones is boiling point and freezing point changes. See, the presence of solute particles causes a liquid range to become wider, which means that solutions boil at a higher temperature and they freeze at a lower temperature. Okay, so instead of boiling at 100 degrees Celsius, a solution might boil at 105. And instead of freezing at 0 degrees Celsius, it might freeze at, let's say, -5. All right. Now, first of all, why does the boiling point of a solution increase? It is purely a physical process. All right. Normally, when a bubble is formed in solution, in order for a bubble to form, you got to have like the water molecules are going to be going inside the bubble. But if you notice, if you have particles, all right, solute particles, they physically get in the way. They physically block some of the water molecules trying to enter the bubble, thus meaning that they need to have more energy in order to do so, and thus increasing the temperature. All right. In other words, a higher boiling point. Now, when you compare bubbles with pure water, see there's no particles. It's easier for the water molecules to enter into a gaseous state, whereas here, there are literally fewer spaces for them to enter into. All right. Now, what about freezing point? All right. Well, freezing point decreases in the same basic way. You see, the solute particles physically get in the way to prevent the hexagonal ice crystals from forming. Okay. They form in a hexagonal shape that interlocked with each other, and it basically looks something like this. Is what, it's almost like a honeycomb type of shape. All right. But if instead of having a water molecule at each one of these points, what if right here there was a solute particle? All right. Well, if you notice, if that's a solute particle right there, then that could not form. None of these intermolecular forces could form, and the entire thing breaks down. So you need to have at even lower temperatures for the particles kind of be shunted off and out of the way so that those hexagonal ice crystals can form. Now, both of these are examples of what are known as colligative properties. These are properties that depend only on the number of solute particles in solution. These physical properties depend only on the number rather than the identity of the solute. Now, other types of properties, such as electrical conductivity, these do depend upon the identity of the solute. In order to conduct electricity, a medium needs to have basically two things: charged particles, and they need to be mobile. All right. So if it's pure water, it's molecular. Pure water being molecular does not conduct electricity. There's no charged particles. But solutions, if they contain ions, okay? If they are solute is ionic, then it disassociates into ions, i.e. charged particles, and therefore will conduct electricity. Charged particles in a solution are called electrolytes. But if the solute is molecular, like sugar, then it is not charged, then no, it will not conduct electricity. So conductivity is not a colligative property because it does depend upon the identity, not just the number of particles. And that's it for today. Thank you very much.